In this video today, we'll be looking at the sine rule, which is exercise 4F from your EMAC book. The sine rule, well, what is it firstly? Well, it finds sides and angles for non-right angled triangles, which I call NRATs. So we use the sine rule to help us find either side length, so we might find side B, the length of that, or an angle using the sine rule. Now, what are we familiar with? Well, what we've looked at before, and I think it was in, it might have been 4A, and let me just get to that. And this is in your booklets too. We had a look at our trig ratios. So we've got, SOHCAHTOA, which is sine, cosine, and tangent with these ratios. We know that the trig ratios only work for when you have a triangle with a right angle. Now, how often does that pop up? Well, unfortunately, most triangles in real life don't have a right angle. You have to have a nice, properly built wall that you lean a ladder on to figure that out. So today we're going to have a more powerful equation that will be able to apply to non-right angle triangles. And we can find either the side length or the angle, much like we did in the right angle trick, using SOHCAHTOA, sine, cosine, tangent, or inverse sine, inverse cosine, and inverse tan to find the angle. So let's start off. Describing angles and sides is a very important first step. We need to label the vertices, big A, big B, big C, and make sure that you use a big A or a capital A to represent these vertices, which also represent the angle. So angle A, angle B, angle C. Now to describe the sides, this is the important bit, we label the edges A, B, and C. Notice how these are lowercase. So how do we know which sides are which? Well, here's our big A. If we go opposite the angle, we find this red line here highlighted. This is side A, so small a. If we go opposite the big B, angle B, we have the small b there, which is the side B, and we have the big C here, our angle C. If we go opposite this, we have our side length C. This is how we label the triangles, and this is essential to know this before we can use the sine rule properly. So without further ado, let's do 4F.1, finding a side length using the sine rule. So we need to find the value of x in this triangle, correct to 1 decimal place. So our first step is to label the triangle. It doesn't matter what letter you start with. I typically always use A, B, C. And I've labelled that counterclockwise. So we've labelled A, B, and C, which represents our vertices and also our angles. So vertex A, angle is 80 degrees. Opposite the angle A is this edge here. So let's label that small a. Across from B is the 7, and across from C is the small c there. Now that we've labelled all that, we need to use our sine rule. You may note there's 1, 2, 3 terms and 2 equations, or 2 equal signs. Now, this may look a little confusing, but really what you need to do is just cover up one and just make an equation out of the other. For instance, you might be just looking at, and I'll just cross out that, A on sine A is equal to B on sine B. Or you might be, if you know your A and C, you might be just looking at A on sine A is equal to C on sine C. So we're going to use, in this case, A, B, B. So we're looking at this situation and that equation. So if we go, we write off the equation. A on sine A is equal to small b on sine B. Our next step is to substitute in the values. We know our A is equal to x. And we know sine big A is 80 degrees. B is 7 meters. On sine big B is 75 degrees. Now, there's a few ways of solving this. Our first step is that we can just rearrange. Note how it's dividing. X is dividing by sine 80, and we want to get x by itself. The opposite of dividing by sine 80 is multiplying by sine 80. What you do to one term, you do to all the terms. So, algebraically, we can go 7 on sine 75 degrees times by sine 80 degrees, and we'll get our value for x as something meters. Now, you do not have to do this in your head. There's always be in the calc section. You go shift divide for our shortcut, 7 on, and let's put in shift 1 for our sine 75, close your bracket, multiply. Now make sure that your calculator is in degrees. If you're in gradians or radians, you're going to be in a world of pain. So press execute. There we go. Now the question says correct to 1 decimal place. So if we go to the second decimal place, it's the 3. We know the 3 will not round up the 1, so it's just 7.1 meters. Now what's another way of doing it? Well, this is a way you can, and I probably recommend it. You go shift equals for the solve function, type in 2 divides, fraction lines there, and then put an equals in between. What we're going to do is we are going to solve. So we're just going to plug in our original equation just here. So we're going to type in x on sine 80 is equal to 7 on sine 75, close your bracket, and then execute. So we have the same answer there. Now, if we had to show our working in this case, I'd recommend you go either do this and write solve and put a bracket around it, like that, and it's just going to load up. There we go. And you can, just to help the marker, just put CP, which stands for class pad. Now, we've shown 2 ways of answering this question using the sine rule. Pause the video now, and I want you to have a go at completing the your turn on the right. Once you're done, play the video, and then see if you got the answer correct. We're going to go through the answer to the your turn now. So, our first step is to label our triangle. You may have done it slightly differently. A, big B, big C. Then label the edges. And then identify which of the sine rules you're going to be using. Well, we don't care about our A's, we have our B's and our C's. So in this case, we're going to be using B on sine B is equal to C on sine C. So B on sine B is equal to C on sine C. We substitute our values in. B in this case is equal to 8 on sine big B, which is 95 degrees, is equal to small c, which is x on sine big C. We now know that x is equal to 8 on sine 95 degrees times by sine 65. And if we plug in, and I'm just going to use our solve this time, copy it down, and I'm just going to put in, this is going to be, oh, still loading up here, apologies, 8 on 95 is equal to, and here is where our variable goes, x on, and our angle across from the C, 65 degrees. Press enter. 7.3, because our 7 rounds up to 2, 7.3, and put in our units, meters. Now in this case, I've also shown the working for this as well. So that's just loading up now, it's just being a little bit slow. 8 on sine 95. Oh, still going. All right, it's like a little bit like magic watching this. So we multiply by sine 65. Okay, the working's catching up now. Man, I almost want to write it out. Times sine 65, come on. Oh, something's happening here. The old pinwheel. It's always good. I think I might have killed my computer. Well, I will have to pause the video here, but we do know that the answer will be 7.3 meters. Just have the pinwheel of death, which is never fun. Alright, I hope you enjoyed the video. In the next video, we'll be looking at finding an angle using the sine rule.